In this lecture, we shall discuss some more problems on hydrostatics, that is on buoyant force and pressure. And as I said already, this notation at the top means the problems are selected from various competitive examination papers. One more part left, which is telling us, let's introduce the question once again. What will be the readings on spring balance and scale pan if the block is pulled up out of the liquid? Let us go for that part now. So returning to equation number 1, which we wrote for the equation of motion of the block, we are getting from equation number 1, I am just writing on the left hand side to accommodate my writing. I hope you can follow all the steps here and the figures, everything is there on your screen. The tension in the string plus the buoyant force minus the force of gravity on the block is equal to 0. And we have been given the tension in the string is the same as tension in spring balance, that is 2.5 kg wet, expressed like this. And the buoyant force, that's also found here, VA into rho L into G. So let's start writing. We have got here the value of T to be 2.5 kg into free fall acceleration G. And the magnitude of buoyant force, that is VA into rho L into G, already has been explained all these things. So this is 3 into 10 to the power minus 3 meter cube, the displaced liquid volume, into density of liquid rho L, which we calculated just now, 1.67 into 10 to the power 3 kg per meter cube into G, free fall acceleration, minus unknown mass of the block A into free fall acceleration is equal to 0. And once again we can see here the G's cancel out, and from here the mass of the block A is coming out to be, we can check it, this is 2.5 kg and this is coming out to be about 5 kg. So together this is giving me 7.5 kg. This is the mass of this block we have found out. Now once you have got the mass of the block as well as mass of the beaker and the liquid are already known from the beginning of the problem, you understand as the block is pulled out of the liquid, the moment it is pulled out completely, there is no buoyant force acting on the block, neither in reaction to buoyant force acting on the liquid, and therefore both the spring balance and the scale pan, they record the true weights of the block and the liquid beaker system respectively. So since the mass of this block is 7.5 kg, the spring ball records a weight of 7.5 kg weight. That is the reading of 7.5 kg only. On the other hand, the scale pan at the bottom records the true weight of the liquid plus beaker system, and that is 2.5 kg weight. And if we talk of the reading, that will be only 2.5 kg. So here are the answers of the part B of the question. The readings on the spring balance is 7.5 kg and on the scale pan it is 2.5 kg when this block is taken out of this liquid.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.